Hello everyone. Welcome back to the channel. Today, we're diving into the foundation of the internet, the TCP IP model. Ever wondered how devices communicate over a network? Let's break it down. What is the TCP IP model? The TCP IP model, also known as the Internet Protocol Suite, is the foundation of the internet and modern computer networks. It is a set of rules that govern how devices communicate over a network. The model is named after its two primary protocols, Transmission Control Protocol (TCP) and Internet Protocol (IP). History of TCP IP model. The TCP IP model was developed by the United States Department of Defense in the 1970s as a way to connect different networks. It was initially used to connect research institutions and government agencies, but it eventually became the standard for the Internet. Layers of the TCP IP model. The model is divided into 4 layers, each with its own role in making communication possible. Ready? Let's dive in. 1. Application layer. This is the layer closest to the user and where network applications operate. T is what users directly interact with, even if they don't realize it. Services. The application layer provides a wide range of services to applications, including email, protocols like SMTP, Simple Mail Transfer Protocol, POP3, Post Office Protocol version 3, and IMAP, Internet Message Access Protocol, handle sending, receiving, and managing email. Web browsing, HTTP, Hypertext Transfer Protocol, and HTTPS, HTTP Secure, are the foundation of the World Wide Web, enabling users to request and view web pages. File transfer, FTP, File Transfer Protocol, SFTP, Secure File Transfer Protocol, and SCP, Secure Copy, facilitate the transfer of files between computers. Remote access, SSH, Secure Shell, allows secure remote login and command execution on another computer. Domain Name System, DNS translates human-readable domain names like google.com into IP addresses that computers understand. Streaming media. Protocols like RTP, Real-Time Transport Protocol, and RTSP, Real-Time Streaming Protocol, are used for streaming audio and video. Network Management, SNMP, Simple Network Management Protocol, allows network administrators to monitor and manage network devices. Protocols. The application layer is characterized by its many protocols, each designed for a specific purpose. These protocols define how applications communicate and exchange data. Data format. Data at this layer is often referred to as messages. The format of these messages is specific to the application protocol being used. 2. Transport layer. Reliable communication. The transport layer is primarily responsible for ensuring reliable end-to-end delivery of data between applications. It breaks down the data received from the application layer into smaller units called segments. Key protocols. TCP, Transmission Control Protocol, provides a connection-oriented, reliable, ordered delivery of data. It includes mechanisms for error detection, retransmission, and flow control to ensure that data arrives correctly and in the right sequence. TCP is used by applications that require high reliability, such as web browsing and file transfer. UDP, User Datagram Protocol, provides a connectionless, unreliable delivery of data. It's faster than TCP, but doesn't guarantee delivery, order, or error correction. UDP is used by applications that prioritize speed over reliability, such as streaming video and online gaming. Port numbers. The transport layer uses port numbers to identify specific applications running on a host. This allows multiple applications to use the network simultaneously. For example, port 80 is commonly used for HTTP. Segmentation and reassembly. The transport layer divides data into segments for transmission and reassembles them at the destination. Flow control manages the rate of data transmission to prevent the sender from overwhelming the receiver. Error control detects and corrects errors that may occur during transmission, primarily with TCP. 3. Internet layer. Logical addressing. The network layer is responsible for logical addressing, IP addresses, and routing data packets across networks. It enables communication between devices on different networks. IP protocol. The Internet Protocol, IP, is the core protocol of this layer. It defines how data packets are addressed and routed. There are two main versions of IP, IPv4 and IPv6. Routing. The network layer determines the best path for data packets to travel across networks. Routers are the primary devices at this layer. Packetization. The network layer encapsulates data received from the transport layer into packets, also sometimes called datagrams. These packets contain the source and destination IP addresses as well as the data payload. Fragmentation and reassembly. If a packet is too large to be transmitted over a particular network, the network layer can fragment it into smaller pieces and reassemble them at the destination. 4. Network interface layer. Physical transmission. The link layer is responsible for the physical transmission of data over the underlying network medium. It interacts directly with the hardware. Media access control. This layer controls how devices share the network medium, example, Ethernet, Wi-Fi. It uses protocols like CSMA-CD, carrier sense multiple access with collision detection, or CSMA-CA, carrier sense multiple access with collision avoidance, to manage access to the medium. 1. TechPioneer.com. TechPioneer.com. Framing. The link layer encapsulates data received from the network layer into frames. Frames include header and trailer information that are specific to the physical medium. Physical addressing uses physical addresses, MAC addresses, to identify devices on the same network segment. Error detection detects errors that may occur during physical transmission. Protocols. Examples include Ethernet, Wi-Fi 802.11, and PPP point-to-point protocol. The specific protocols used depend on the type of network connection. How the TCP IP model works step by step. When you're sending data. When a user initiates data transfer, such as sending an email or browsing a website, the data is first created at the application level. To ensure efficient transmission, large data is divided into smaller units called packets through a process known as segmentation. The data then moves down through the layers of the TCP IP model. Application layer prepares and formats the data for communication. Transport layer adds headers containing port numbers and error checking information, forming segments for reliable delivery. Internet layer assigns source and destination IP addresses, converting segments into packets for correct routing. Link layer adds MAC addresses to create frames, making the data ready for physical transmission. Finally, the frames are transmitted over the network using physical media, such as Wi-Fi or Ethernet, carrying the data to its destination. When you're receiving data, upon reaching the destination device, the data arrives as frames through the network medium. The data is then passed up through the layers of the TCP IP model for processing. Link layer verifies the MAC address to ensure the frame is intended for the device and removes the frame header. Internet layer checks the IP addresses to confirm correct routing and strips the IP header. Transport layer reassembles the segments into the original data and performs error checking to ensure data integrity. Application layer delivers the processed data to the appropriate application, example, a web browser or email client. This structured process ensures accurate, efficient, and reliable communication between devices over a network. Importance of the TCP IP model. The TCP IP model is the backbone of the Internet and modern computer networks. It provides a standardized framework that enables devices, regardless of their type or manufacturer, to communicate seamlessly. By defining clear rules for data transmission, addressing, and routing, the TCP IP model ensures reliable, efficient, and interoperable communication across diverse networks. Without this model, connecting different devices and networks would be chaotic and inefficient, making the internet as we know it impossible. Its widespread adoption allows for services like web browsing, emailing, streaming, and file sharing to function smoothly worldwide. That brings us to the end of this video. I hope you now have a clear understanding of the TCP/IP model and its working process. If you found this video helpful, make sure to like, share, and subscribe for more informative content. Thank you for watching, and I'll see you in the next video.